So my name is Ian Barber. I'm a developer programs engineer with Google, and this is my colleague Mandy.
And I'm Mandy Waite. I'm a developer advocate for was for the Google Cloud Platform, now for Scalable Outreach.
So we are going to talk about the Google Cloud Platform, specifically App Engine and specifically PHP on App Engine. And there's a bit of a division between us where Mandy actually knows about this stuff and I've done some PHP in the past. And this is how we ended up talking in October at PHP Northwest about App Engine and PHP. And in that case, we actually joined in. We wanted to see how long would it take to take a site which is MVC, which is, maybe not the world's most consistent code base, and get it on to App Engine. And it took about 3 days. It wasn't that hard. And so we talked about that then. But for you guys, we thought we'll do something a little bit different. We go in another direction, specifically one direction.
So how many of you guys have heard of the band One Direction? I was going to say when all your hands went up, I was going to say, so how many of you are fans of One Direction? Which would have probably had less hands, but okay, so what's that? I know. But you still heard of them, right? Yeah, come on. So anyway, back on November the 23rd, One Direction, the boy band, did a live stream. What's that?
The sensation.
The sensation, the boy band sensation. They did a YouTube live stream, 7-hour live stream, the biggest live stream ever on YouTube. And One Direction happened to be the biggest social media entity on the planet. They have like 17 million Twitter followers, which is close to what you have, right?
Yeah, it's in the ballpark.
Right, okay. So, as part of this live stream, they wanted to build a second screen application, a screen that people could use while they're watching the live stream that they can interact with on maybe their mobile device or maybe on their laptop, anything like that, but it's a quiz app. So about 3 or 4 weeks before the event, they brought in an agency to develop the code for it, and we helped them develop this application, this one D-Day quiz. And it has one main feature, well, 2 main features really, right? So one is that it never falls down, so people don't get a bad experience with it, and one that it scales to handle hundreds of thousands of users. Potentially, 16 million Twitter followers, I mean, they could have been millions, but it was probably going to be in the hundreds of thousands. And this is the kind of traffic pattern we got. This is a summary window from App Engine, the application running on App Engine, and this is queries per second. So this is a spike. We'll talk more about the architecture of the app and how we deliver questions. In fact, we have a surprise in store for you. This basically shows queries per second over time.
Oh, you're on that one again, sorry.
Yeah, queries per second over time. And that's quite impressive. This is like 750 QPS, sustained over a long period of time.
And we had a much, much bigger spike in that as well.
What was it? 9,000 QPS.
Yeah, so we are spiking into that. And obviously we can't use this application, so we have this application. So actually the app was built with PHP. The 1D app was built using PHP on the front end. But we wanted to build something kind of for you guys that we could actually share the code for. So I made this, and the front end, much like the 1D app, is in JavaScript. And as you can see, my design skills pretty much at the same level, pretty much there. So yeah, you can try it. It's phpukquiz.appspot.com. So it'll work on mobile, hopefully, and it'll work on desktop, hopefully, and assuming the Wi-Fi's up. And it works exactly the same way as the original One Direction quiz. So what happens is every so many seconds, about 5 minutes, you're going to get a new question about something that's happened over the last 2 days of the conference, one of the talks, or some of the content, and you get to answer it, and there's a score at the end. So this model is exactly how they built their app, but with a slightly smaller user base.
None of you guys have got desktops though, right? With you. You mentioned desktops.
Desktops and mobile, yeah.
Okay, all right, so basically one of the questions that came up, and I think Glenn Campbell touched on this subject this morning, is why cloud for PHP? How many people are running PHP in the cloud today? Okay, that's a good number, so it's quite a few of you. So one of the reasons why you might want to run, thank you, you might want to run PHP in the cloud. So let's think about this. As developers, for a long time we've been constrained. We've been constrained not by our imagination, by the things we can build, in our minds at least, but by the resources that we have available to actually build it. And in the days of cost-effective cloud services, virtual machines in the cloud, storage in the cloud, other services in the cloud, the reality has now changed, and we now have the ability to build what we want, build what we can envision. So all of those kind of constraints have gone away. Also, we want the ability to be able to scale on demand, and to have the resources that we need when we need them. We'll talk more about scale in a couple of slides. Also, with some cloud services, platform as a service, they give you fully managed software stacks in the cloud, and that means you can spend your time focusing on developing your application code and not building systems or configuring and managing software stacks. Another great feature of the cloud is the ability to gather analytics. Now, you can gather analytics anywhere, but data tends to get big, very big. You need lots of space to store data. The cloud is a perfect place for storing data. And it also provides tools on which you can run analytics across that data to gain insight into how your application is doing, how it's performing, how your users interact with the application. That can give you the ability to actually update your application and tailor it to suit your users' needs. Then there's global availability. Now, you can develop your application, deploy it in a server in London, and that's great for people in London who can access your application. But what about the guy in Beijing? How does he access your application? So now, you're not going to deploy your application everywhere in the world. You're going to have it running in one place. But with data centers everywhere in the world, users can connect to your application very easily from a local data center. We can cache content very close to the user using edge caching or peering relationships with ISPs. And once the user is connected to the data center, we can get their request to where the application is running very, very quickly. You could build it yourself, and I'm not really going to talk on this slide. This kind of slide takes me back to the days when I used to configure systems. Just look at it. You know what it's like to build LAMP stacks and to configure machines and databases. You don't have to do that in the cloud. You can, but you don't have to. You can also try to anticipate demand. And this is where autoscale comes in. Now, your demand traffic patterns, they change. They change dramatically. You could be slash-dotted, you could be tech-crunched. And your traffic demand on the application could grow very rapidly, overnight even. So how do you deal with these kind of spikes in traffic that we have here? How do you deal with situations where you have pattern-based traffic demand, where you have some level of usage, then the usage goes away, maybe overnight or something like that, or seasonal traffic patterns where you have resources available that aren't being used because you have no traffic? How do you handle linear growth? How do you handle exponential growth in traffic demand? So really the focus of this talk is App Engine. So you saw it in the title. So we're going to be talking about App Engine mostly, or at least in the context of App Engine, PHP. And App Engine is a platform as a service offering. It gives you fully managed software stacks in the cloud. And I could list a whole bunch of bullet points here detailing App Engine's features, but I'm going to stick to a few. The ability to auto-scale. This is the ability to actually handle the traffic that's coming into your application. Not necessarily big peaks, but also small troughs as well. So that you have the resources you need when you need them, and you only pay for what you use. Also, it's completely free to start. You have to have a Google account to sign up for App Engine, but you don't have to put in any billing information. You don't have to put your credit card in. You get a reasonable amount of quota per day that you can use to have your application serving requests from users. Also, we have SDKs for our language runtimes, which I'll talk about in a minute. And the SDKs give us local development environments in which you can develop your application and run and test it. Also, we have access to service abstractions, cloud-scale service abstractions, things like memcache and Datastore. And through App Engine, you also have direct access to Google APIs such as Maps, YouTube, Google+. The software stacks that we have are what we call language runtimes. They're fully managed. The languages we support are PHP, yay, PHP, PHP, and Python, Java, and Go. These are fully managed for you. You do not have to apply any patches. You don't have to apply any updates. And they are maintained for us by what we call SREs, site reliability engineers, who we have enormous respect for. They carry the pages. They're the guys that get woken up, the guys and gals who get woken up with their pages when anything goes wrong with App Engine. One thing I just want to kind of touch on as well is this kind of difference between platform as a service, where we have tools such as App Engine, which provide software stacks, and infrastructure as a service, which provide virtual machines in the cloud. So now we've already established that App Engine, the platform as a service offering, is perfectly suited for these web-type workloads, and also perfectly suited for mobile and cloud, mobile and gaming backends. It's great for undeterminate type traffic patterns and also for auto-scaling. Whereas something like infrastructure as a service could do all of that. You could write your own paths if you wanted to. You could run Heroku, say, on Compute Engine, or you could build your own and run it on Compute Engine, our infrastructure as a service. But Compute Engine and infrastructure as a service generally is best suited for compute-type workloads. Things such as batch processing, running MapReduces, doing things like Monte Carlo simulations, or one thing we saw last year was the Atlas project at CERN used Compute Engine as part of a hybrid cloud, which is really cool. Platform as a service and infrastructure as a service can both do one thing really well, background processing. They both do that equally well. You can do it on either. But in the middle, there's this capabilities chain. App Engine can do what it does because it's very opinionated. It wants to do things in a certain way. That's what gives it the ability to auto-scale. And you have to imagine here, when I'm talking about auto-scale, I'm talking about the ability to really respond to rapid changes in traffic. To scale up very quickly without seeing extended periods of high response times. So the one thing that App Engine and some other platforms of the service can't do very well are things like some languages. We've already listed the 4 languages that App Engine supports, and that's all it supports currently. Also, what about extensions for the language? Also, what happens if you need root access to your virtual machines? You want to run some software on that. Alternative PHP stacks. We have PHP, Ian's going to talk more about that later, and also WebSockets as well. So there's this kind of middle ground where platform as a service isn't perfectly suited, and we really want to actually push all of that work to infrastructure as a service.
Yeah, so I wanted to talk a little bit about what it's like to run PHP on App Engine. And as kind of Mandy was describing, it's a choice. It's the choice where most of the work is done for you. But you've got the other end of that choice, which is running your own stuff on Compute Engine. And hopefully, as you'll see, it's pretty easy to actually mix and match how you run different bits of your stack, how you run different bits of your system. So if you want to run HHVM and your own builds on compute instances, you can do that. But on App Engine, you really need to know about 3 areas, I think, to understand what you will need to change in your PHP code to make it run well. App Engine effectively works a little bit like Nginx and FPM. So instead of it being a module that's running in a web server, there is a web server, like Nginx, it's the Google front end, that's going to take requests and it's going to send them across to the application server. In FPM, that would be FCGI to the actual FPM instance. And in App Engine, that is App Engine. So that's where your application is going to run. It's going to be spun up on an App Engine instance. And you can think of that almost like a process. Like if you imagine the whole Google Cloud as one machine, this is like a process is spinning up to handle the request. That's how an instance is treated. So there are some things that you don't get in the request. Like if you want to set the keep alive settings, no, because you are not the web server. The web server is not communicating, you are not communicating with the outside world directly, you are going via a web server. So keep alives, things like that are handled by the request, handled by the GFE, not by you. On the other side, it does mean you get some benefits, like you get things like DOS protection built in for free. You can easily blacklist IPs and it costs you nothing. And it means you get additional information like geolocation information. You're going to get the country, region, city, that kind of information. Just in the request, it just turns up in the server superglobal. On the response, it's pretty much the same, pretty much whatever you would expect to be able to write back, except there are some limitations. So you can only really do a request response model. If you want to do a kind of React style, bring up a service and have it handle loads, it's not a good fit. That's not what App Engine's for. You can use Compute Engine or anything else if you want that. It's also got a limitation. You can use up to 32 meg in a response. So you can't send anything larger than that. If you need to send files, there is a separate cloud storage system, a block store, as you might expect, that can send large files out. But as your response, you're going to have to limit yourself to 32 meg at most. You're going to have to limit yourself to a 60-second response time. So you've got to execute in that time. For most of us, this is not unusual, 60-second response time. For some of the other platforms, it's a bit strange. Java people sometimes question these kind of things. We've also got to think about the kind of encoding we chuck out. You can't do chunked encoding. You can't do, because again, we're not streaming, so we're not going to send out part of a response and then some more. We're sending the whole response to the Google front end, which may then communicate it in different ways to the server. Such as, it might automatically use Speedy if the client can support it. And you don't have to think about that. And you can optionally turn on things like page speed as well. And finally, you've got the actual execution environment. This is like what the PHP is running in. And it is PHP. It's C PHP. It's not running on the JVM. It's not some funny version. In fact, it's a fork of PHP 5.4.19 at the time of writing. And the reason it's a fork is because some of the changes needed to run well on App Engine had to be made at that lower layer. And if you want to see what's in that fork, it is all on GitHub. You can't quite see that link there, but all these slides you can get at the end. They have all the links on. But it's on GitHub. You can go and look at the code. You can go and look at the changes made. There's nothing odd in there. It's mainly tweaks to make it work with the infrastructure. And as an example, when we do URL fetching, when you do file get contents, that doesn't come straight from your instance. It goes via our URL fetching service, which is a lot better for a lot of reasons, but you don't have to care. You just go out and you fetch a URL and it comes back. The PHP limitations that will tend to get you are the fact that this instance, it's like a process, or maybe even more like a thread. It can be spun up and it can be spun down. So you cannot rely on things being there. And in fact, the file system is totally read-only. You cannot write to the file system. Most of the time, this doesn't matter. Sessions are automatically stored off into memcache. You can push data that you need into memcache. You can push it into Google Cloud Storage if you need a file system right. And of course, that'll be applicable across App Engine instances. But you can't, for example, write some stuff into temp. You can't log files directly to var log, that kind of thing. So in some cases, applications need a little bit of tweaking. For example, joined in did. Now, what we built, and if the Wi-Fi is not working, you haven't had a chance to see, roughly what it looks like is this. We've got 3 sections of this little quiz app. And while this quiz app is based on a real thing, it is based on the thing the One Direction agency did, and it is based on something that was scaled very successfully, think about instances out of your own work where something like this might be applicable, where you might have built a microsite or a campaign site, or where you might have built a component of something you work on. Because those kind of questions that you might come up with about how would I do this, how would I put this onto App Engine, those are the things this is a great time to ask. Like, having Mandy here, you've got an awful lot of knowledge available. So if you do start thinking, hold on, but in my setup, I would have this problem, please ask that, and please think about your own problems in this. But this thing is very simple. We have a login, so you come in your authenticator, you've got a login, we've got to authenticate the user so we know who's answering the questions. We've got a question timer, so we get back questions, we know when the next one is, and then we're going to show it. And then when you get a question, you have to answer it. So someone chooses an answer and sends them back. Same thing, except slightly different topic to the 1D app. And we built that just the same way. So we had really most of the work in JavaScript, because then it's more scale, right? We don't have to do a request response round trip. We don't have to do extra processing on the server at all. It's faster, it's less request, great. So we do almost everything in JavaScript with just a little bit of configuration from PHP. So PHP's outputting some HTML at the start and then kind of getting out of the game at the front end. And then we have a bunch of kind of RESTful services, just things that you send form posts to and you get JSON back. It's not even to the level of calling it a service, but it means we have this very clear front-end, back-end delineation. Now the front end is all JavaScript, and the back end is a little tiny bit of PHP using Silex. So that's using Composer that was just built exactly as you would and then deployed up to App Engine. And at the bottom, we've got a Datastore. Now I think a lot of us, if we were building something like this, you just build it, right? You just build a controller that gives you the home directory and a controller that exposes some functions for, the getting questions, getting the user, sending the answer. Because it's easy, we deploy that thing and we're done. But there are 2 very clear different layers here. We have the layer for the JavaScript on the front end, we have the layer for the back end, and they're not really the same, but we treat them the same because it's simple to do so. And one of the really great features about App Engine, and this is something I didn't know about last time we did a talk like this, is something I discovered as we're going through it, is how easy it is to take sections of your site, sections of your one code base, and split them off into what App Engine calls modules.
Passing the baton, like an Olympic event. So did anybody notice there's a door in the wall? Like. And also Ian's application has a picture of a sloth in it, and he's very proud. So hopefully you're playing the application, playing the quiz and getting along so you can see the sloth. So App Engine modules. Sorry, that was a bit of an aside. App Engine modules. So App Engine, anybody who worked with App Engine a couple of years ago probably knows the fact that we used to have front ends with back ends and back ends with front ends, and it was all quite complicated. So with PHP and with all of the other languages, we now have this feature called modules. And that allows us to effectively take a very big application and batch it up into small bits, into small modules. And modules are all pretty much the same, apart from something we'll look at on the next slide, and they can run parts of your application. This could be something you might expose externally to users, or you might just use internally to do internal type stuff, like back-end stuff, like long-running processes. And all of these modules being the same, they all have versions, so you can have different versions of different modules. Versioning in App Engine allows you to actually deploy multiple versions of your application and then do things like traffic splitting, do A/B testing across multiple versions, which is really cool. And versions have instances, and these instances have some differences. We'll look at that on the next slide. But these instances can also be compute engine. Remember we looked at compute engine earlier, and we looked at IaaS, and we looked at PaaS. And these instances can be compute engine virtual machines and can run pretty much anything you like. So you're not kind of restricted to the 4 languages. Ultimately, you'll be able to run anything on these backends. So these managed backends, as we call them, or VM instances, or we have lots of different names for this product that we're going to release. It's in Trusted Tester currently, but it looks really cool. The thing that makes modules different is the scaling type. And so we have 3 different scaling types. We have this kind of routing, I'm really stuck with the American use of the word. This routing tables, dispatching to different URLs based on the incoming request. Ian's going to talk more about that later. But we have 3 options for scaling. We have manual scaling. Manual scaling means you're basically responsible for adding more instances as you need them. So you might have 5 instances or 10 instances. Basic scaling allows you to say, well, I'm going to have 20 instances, and we'll use some very simple algorithms to scale within up to that maximum. So if the traffic increases, we might pull in another instance, but we won't use a very complicated algorithm. Auto-scaling is the App Engine classic auto-scaling, and that works on a very complicated algorithm that works extremely well. So this is basically just a property of modules and kind of separates them and defines them.
Yeah, so all the modules we're going to use, we're just going to use 2, one for the front end, one for the back end, and those are going to be both App Engine modules. You can mix and match how you need in an application. Now, if you're thinking of setting up a LAMP stack or an Nginx stack or whatever, you're generally going to think about setting up some host config on the web server, and then a mod rewrite rules, these kind of things, that do your routing from URLs to your actual controllers. And App Engine kind of splits that up a little bit. A bunch of App Engine stuff you set up on appengine.google.com. And you can go there now, you can set up a site, you can see all the many, many configuration options on the dashboard. But that's like one place. You can define the domain name there. You're going to be able to deal with certificates and so on there. That's like the central project. And then you've got the actual application. And that's configured in a YAML file, which should please Symfony fans. You indicate which application it is. So you give it your application ID. Ours is PHP UK Quiz. And you can then specify the version. As Mandy said, if I have version 1 and I want to test version 2, I could update my YAML to say version 2, and then I could deploy that and have both running, and maybe put 10% of traffic to version 2 to see if it's breaking things. So you can do ramps and you can do rollouts and all that good DevOpsy stuff. You've got the actual runtime you're using, so we're PHP, and the API version, which is the runtime version we're talking to. 1 is the only one for PHP. And thread safe, which is, don't have to worry about too much in this case. So that's all app configuration, and that's just connecting the code you're uploading, the code you're going to deploy to that App Engine instance. The next bit is this handlers section, and the handlers section is kind of equivalent to your htaccess, right? It's kind of equivalent to your rewrite rules. You can't do everything in it that you can do with mod rewrite. And you can do some things in it that you can't do with mod rewrite. So they're not quite an even match, but broadly, I think for most modern PHP applications, you're going to have some static content, files, JavaScript, CSS, and so on. And you're going to have a front controller, and you want to route all your requests to a front controller because spin up your MVC stack. And that's what we've got set up here. We've got a URL static, and all our static stuff lives under there. And we've got a rewrite of everything else to index.php. So that's where our front controller lives. Very straightforward. The static thing here is a bit more clever. It's not saying just route it to these files if they exist. It's also saying this content is static. You don't need to get it from an App Engine instance. You can go and put it on some edge cache. You can go and put it further forward in the network. So that information is cheaper to serve and is faster to serve than information that has to come dynamically, which is great. Now in this, we also have the backend. So that app YAML was the default. You'll always have an app YAML. But we're going to have a DB YAML as well. The DB YAML is our module for our backend. So this is for the get questions call, the set answers, the get user. It looks pretty much the same. You'll see there's the extra line in there, module. Module just says this is another module in it, and we have another set of handlers. You can see, because we're using Composer, the source path is slightly different. But all of this is one file system. You know, we're deploying one thing up to do this. I've not split them up at all, though I could. And then finally, we have this dispatch.yaml. And this is another file that allows us to control routing to modules. Now, modules can be accessed by default. So they automatically are going to append the module name, and you can append the version name, and so on. So you can target modules automatically. But a lot of the time, you want to do the routing under one domain. You want certain chunks of URL to go to one module, certain chunks to go to another. So in this case, we're sending all of the DB requests to our DB module. So it presents as one URL. It's under one HTTPS certificate, but it's routing to quite different things, which can be scaled quite differently. So the application is not complicated. If you've seen it, there's a bunch of JavaScript, but you can see that it's not super interesting. The backend is a Silex app, and it's taking some calls. And the only really complicated thing it has to do is get a list of questions and write back a list of answers. And those are just database operations. So we had to decide, where do we store the data? That's the big question of this kind of application. And that is a slightly different decision that was made here than we did with Joined In. With Joined In, we used a thing called Cloud SQL, which is MySQL in the cloud. With the 1D app, they didn't want to use something like MySQL because they have those two entities, questions and answers, and there's no real relation. Like, you might look up all answers by question ID, but you don't need set operations for that. So they wanted to use something slightly different, and so they chose to use a service called Cloud Datastore.
Okay, so I don't think I need this, right?
Yeah, you've only got one slide.
Okay.
Thank you.
Okay, so the Cloud Datastore. So first, we talk about white papers. We've had several white papers at Google over the years. One of them is GFS, Google File System. On top of Google File System, we built this thing called Bigtable. And Bigtable was used for storing a lot of data in Google, and historically is one of our most used data storage systems. On top of that, we built a thing called Megastore. Some of the things that Bigtable didn't do quite well were fixed in Megastore. And on top of that, we built a data store. And then we built App Engine around that data store. App Engine and data store have a real tight affinity with each other. The data store is effectively a managed NoSQL schemaless database, or data store, if you want to use that word. And it's massively scalable. It scales without you having to do anything. You don't have to worry about handling the scale. We'll do that for you. So the more data you throw at it, the more spread out that data is. It's effectively sharded across multiple systems, multiple data centers. It automatically scales depending on your needs, effectively. It's completely object-oriented, object-based. We have entities, the idea of entities and entity groups. We also have a robust query engine. The term robust came from a marketing slide, I'm afraid, and I couldn't quite really work out what to replace it with. So a robust query engine that does SQL-like queries. It does atomic transactions. All of that from Java and from Python, we can access natively from within App Engine. We have a native API. From PHP, we don't quite have that yet. It's in process. Hopefully we'll have it at some point. So for PHP, we used a thing called the Cloud Datastore. This is the same thing under the hood, but it's an API. So we can effectively access the data store from anywhere. So even your application data within App Engine, from your Python and your Java applications, can be accessed via the Google Cloud Data Store. And that's pretty much it for that slide.
Yeah. So, as Mandy was saying, Datastore in Python and Java, if you look at the code to access it, it's very nice, it's very elegant. And the code in PHP is not nice or elegant. So we'll look at it, and hopefully it won't be too bad. But it's accessed via a RESTful API, so there's a few hops you have to go through. We have to set up a API console project. This is automatically created when you create App Engine, but you've got to turn on the APIs you want to use. In our case, we're using the Cloud Datastore API, and we're using Plus, which is just to get the profile information of the user. This is a place you will find yourself going to if you want to use any Google API, so hopefully it should be fairly familiar. And when you do turn it on, you get access to a nice console. So the console will let you see what kind of entities are in there, what the usage is like, and you can go in and do all the normal create, edit, delete operations on entities directly through this, which is very, very helpful while testing, which is why I wanted to put it in here, so you can just poke things in and out as you're trying to get everything else to work. Now, this is really going into the code of how this stuff is done. I've tried to focus on the code that is relevant and the code that is related to the scalability part, the things that help you actually make these calls and then make them fast. To actually access Datastore at all, we are going to use the Google PHP client library. This is okay. It is a 5.2 supporting client library, so we have underscorey names. We don't have namespaces in it at this point. It's on GitHub, it's on Composer, so you can just include it and it's going to auto-load, so at least you don't have to worry about it too much. And when we use this, we need to authenticate ourselves to the Google API service. Now, normally with something like OAuth, you're going to do an exchange, you're going to get a code back, you get a token. You use that token to say, I am acting on behalf of this user. But in this case, we're acting on behalf of the application. We'd say, I would like, as this bit of code, to access data that is owned by this application. So for that, we use something called a service account. And all that is a private public key pair. You create it through the API console, you download the private part, Google keeps the public part, and you sign requests with it. So you sign a request and say, this is from me, and I would like an access token for the Datastore API, and I would also like to have the user info email scope. And that's just because service accounts are identified by email. So these two things are saying, give me back an authentication I can use to query the Datastore. So once you've done that once, you don't have to worry about it kind of again. To actually make the query, we're building up a fairly annoying object structure. So there are a few levels of this, but hopefully you can kind of see where it's going. We have a Datastore request. The Datastore request contains a query. The query object contains a kind. That's like a collection in Mongo. It's like a table in SQL. It's, you know, it's the type of the entity that you're trying to retrieve. Our kind is question. We're then going to add a filter. So we're saying of the questions, we would like to filter them by these things. A property filter. So in fact, we're going to look for the start time property. We're looking for start times which are greater than or equal to this value, the value being the current time. So we're saying, give us all questions which are greater than this time, and then we're going to order that, so we want them in ascending order, and we're going to filter it. So we just take 3. So we get back the next 3 questions. The code, as I said, is a bit verbose. We got like 3 pages of it here. It is 1 line of Python. Hopefully we will get to the point where we have an equivalent API in PHP, which is actually making the calls over protocol buffers, actually. Which is how it's done in those other languages. So to make the call, we need to pass that request we built up to the Google client object, and when we do so, we just call run query with a dataset ID, and the dataset ID generally equals our project name. So our dataset ID is going to be PHP UK quiz. That's just saying you can have multiple of them, but the one you get by default is going to be PHP UK quiz. So in general, we're going to go and make the call to that dataset and get back our next questions. But while we're querying Datastore, we still have to think about things like performance. Datastore is quick. Datastore is going to execute quickly and it's going to get your data back quickly. But that doesn't mean we want to hit it every time. We also want to think about cost. When you're playing with this, you're going to be entirely in the free quota, so it doesn't matter. But if you are going to have thousands of teenage girls hitting a site, you don't want to go and retrieve all of that data every time, because part of the cost structure of Datastore, so what you pay for Datastore once you get over the free quota, is based on reads and writes. So if you can avoid doing them, you should. So we want to introduce caching, and we can do caching in two places very easily and very cheaply. The first one, fairly obvious, is memcache. And memcache actually has a couple of different options in App Engine, right?
It does.
There's no slides.
No, I'm going to take it.
You're going to go for it?
Yeah.
Okay.
Now I can hand it over to you. We know when we're finished. But basically, memcache is one of these big cloud scale services that we have. It's available to all of the applications within App Engine, but it's shared across all of the applications in App Engine. So the eviction policy will likely mean that your data could be evicted from memcache by somebody else's data. That's okay. This is perfectly free. It may not be the best option for you. We also have an option for dedicated memcache, in which you can reserve by gigabyte for a certain price some memcache of your own. So effectively, you'll have your own memcache service available to you. And that way, your data will only be evicted from memcache by your own data.
Cool. So which one you tend to go with is going to make sense on price, how much you need the caching to happen, and that kind of thing. You can actually go wrong by getting getting reserved memcache, but not getting enough. So you find you're actually churning your own data too much. In this case, we're just going to use a free memcache, which worked completely fine all the way through. I was testing this, did exactly what I expected, and it works exactly like regular memcache. We see we are creating a memcached object. There is also a memcache object type, just like in PHP. It is the same object as in PHP. This is one of the core modifications that we're making. And the difference is just there's no connect. We're not connecting to a port, we're not connecting to an IP. It's just connected to this kind of cloud memcache that's out there, so you don't have to worry about it. And if you do get a reserved instance, you don't have to, a reserved space, you don't have to pass any connection string as well. It'll automatically use that. So there's like no configuration required. The other thing we can do for scalability is output cache control headers. And these are honored. So we can output this header that says max age 60 seconds, and it means that the front ends and our edge caching network will keep this data and will serve it preferentially from there up until that point. So we can avoid those requests even coming into App Engine, even requiring bouncing out to memcache. They just get handled at the edge. Now, if you're using either of these things, there's consoles inside appengine.google.com. This memcache viewer is great, you can see stats and so on, but the really important part is there's a flush button, so when you're developing it, you can flush it and make sure things work. And the other cool thing is one of the dashboards that Mandy showed me the other day. If you change the chart type to request by type per second, you can see what kinds of usage each of the different types of data have had. So you can see on there dynamic requests, that's where your App Engine instance is doing something. Static requests, so those are requests for those static files which you identified in your app YAML, and then cached requests. So these are things that have been caught by the edge cache. And you can really see, hey, is my stuff being cached properly? Am I avoiding having to deal with that traffic at all? So that's reading, and reading is pretty scalable because reading is inherently cacheable. If you have data like this, where that data is valid for like 5 minutes, we can chuck it in a memcache, we can chuck it in an edge cache, and it's going to work. But we also have answers, and we have to handle the answers as they come in. But there are still some tricks that the 1D app used to make sure this was as scalable as possible, which we'll go through a few of them here. The first one, and one I've really, really liked, is you remember that spiky chart that we saw at the start that had all the things? That was every time the question appeared. So the questions in their version of the quiz appeared every 10 minutes rather than every 4 minutes. And at the start, the fans would see it and they would immediately answer it. There was no wait. I mean, it was like 5 seconds of question answering and then the rest of the 10 minutes waiting for the next one. They knew the answer instantly. So they're going to just jam on that thing. So even though you go, okay, we might get N100, N1000, N whatever people answering this spread over 10 minutes, that's fine. It wasn't spread over 10 minutes, it was spread over like 3 seconds. So to avoid that, they introduced jitter into the actual post. So when the post happened, rather than just doing a bit of Ajax immediately, saying here's the answer, randomly delay that. So put the actual post in a set timeout, give it a random time, and that just diffuses that spike over 10 seconds, 30 seconds, a minute. Now, in some cases, those wouldn't make it, right? Some users would close the browser. But if it's this kind of information, you're not that bothered. It's better that it stays up. It's better that you have this smoother load graph than it is that every answer definitely gets recorded in the database. Obviously, that's not going to be true if you're doing e-commerce transactions. But some of these same ideas work. Diffusing some of that load over a wider time span can really help give you more predictable performance. Now, once the request actually makes it to App Engine, we don't want to hit the data store if we don't have to. So we can just store a very lightweight counter or value in memcache saying, have we seen this before? So we write the question ID and the user ID into memcache and say, if it's already there, so we can't add it, just fail. There's no point. There's no point. We've already stored a user for an answer for this user. So either it's just a double send, or they've got it open in multiple windows or whatever. We don't need to do it again, but we also don't need to give them a problem. So we can return a 200 to them. We can return all is okay. We can also use this point to calculate some lightweight information. So, for example, we increment the user's score in memcache, so that if they reload the page and they need to update their score, they get their score again, we don't have to go to a data store and calculate it. We can just grab that out of memcache. It's mostly going to be there, and it's mostly going to be fine. So it's just these things to try and make the majority case fast. And this is a trick that I thought was really good. It wasn't needed, but as an idea, I think this is fantastic. And the fact that you can put this into a little campaign app means you can really do this kind of thing if you're building a bigger, more serious application. And what this is a pressure valve. So if you're getting too many writes, if they're, no matter how scalable a system, there can always be hotspots. And if for whatever reason you're hitting a hotspot, a lot of writes going into the same cluster, and you just aren't getting the right performance out of it you need to, in this case, they could go and write into memcache a certain value and change what percentage of requests would actually hit the data store. So instead of having an application perform really slowly, or instead of having it go down even, the people running the quiz could just back off the right percentage. Some of the users wouldn't have their answers written, but they would never know, and everyone else would have a better experience. So it just let them let off pressure if needed. It wasn't needed in the end, but I think it's a fantastic idea, and it's super easy to do. You just have to check for a value in memcache. You never write that value. That would be written through an interface like an App Engine or Google.com if there was a genuine problem, if you were seeing that in the logs. So, if we've got through all that and we are doing a write, we again use the Datastore API. It looks like this. We have a transactional, non-transactional request, which obviously implies you can do transactional ones if you want to batch up a bunch of changes. We have a type, in this case answer type, so that's again like a collection, like a table, and we have an ID. Within that, we have an entity which has a bunch of properties, and each of the properties kind of looks like the user ID one there. Now, this data is actually typed. So you set a string value or an integer value or a Boolean value or a float value. So you do have to think about the type of the data you're sending. You can also set here a flag called indexed. And if you do indexed, it will not only write in to that entity store, it will also write a pointer into an index so that you can do much, much faster queries on it. So in the case of the answers, we don't really index it because we don't need to do any quick queries on it. But in terms of the questions, we actually index the question ID and the start time because we use those. Finally, we put it into an upsert here. So the actual mutation we do to the data store is an upsert. So that's an update or an insert. If we wanted to, we could just do an update, just do an insert, delete, all those kind of things. So it's pretty much as you'd expect. And you notice we can pass an array here. So if we wanted to send multiple changes at once, we could batch them all up, save ourselves a little bit of network time. All of this stuff, when it's going to a Google API, is actually going within Google's network. So it's pretty fast, but less network calls is less network calls regardless. To actually make the call, we simply write into the data store client and we're done. But we can get an exception. Things can go wrong. We could have an interruption. Even if we've sent perfectly valid stuff, there's always a chance of a failure. And we probably don't want to just output it to the user like this. That's not that helpful. But we may not be able to do anything useful with it right then. So we might want to think about logging. And logging is difficult if you can't write to a file system. If we can't go to var log and get it, we need a slightly different approach. And so the way App Engine handles it is syslog, anything going towards syslog, anything that would be going to the SAPI log is automatically collected and sent to a central login repository, which you can actually access through App Engine or google.com. And this has a couple of decent features, I think.
I think it does. I need this. So yeah, basically, so login is quite extensive. It's a really good interface. And we have one important feature. So how many of you have had the frustrating experience of having to look through a log file for something that was happening in a different time zone and trying to equate the time zone or the events with the time zone that you were in and trying to work out when things happened? You can actually change the time zone of the login here, up here on this option here, and to your local time zone. So you can see everything relevant to your time as opposed to the time in which it happened for the application. So that's really powerful. But you can also export data, all of the login data, into BigQuery. So Google BigQuery is a tool that allows you to run analytics, interactive analytics effectively across massive data sets. And it's got an SQL-like syntax, very easy to use. But this would effectively allow you to import all of your log data, and it could be a huge amount of log data, particularly with something like the One Direction app where we're having so much traffic in such a short period of time. So you can run BigQuery to do analytics across that to look at what is going on.
Cool. So there's only a couple of areas really left in the app. So much of it is just writing and reading questions. So just in case you're wondering, syslog works, but if you plug this into monologue or something, it would go just fine. So the first thing is we have sign-in, and if you've looked at it, you may have seen that it's using Google Plus sign-in. And the first thing to be aware of with Google Plus sign-in is it does not necessarily require Google Plus. So in this case, we're just requiring the scope called profile, which just means you need a Google account. And the reason we're using this is because we can use a JavaScript API and do everything within JavaScript. We don't actually have to go back and hit the user until the user has signed in. So we don't have to hit the server, sorry. We define the parameters for our sign-in in metadata, and we create a sign-in button just with a tag here. To make that all go, we need to include a loader JavaScript, which sits at the bottom of the page, and this will automatically, as soon as it has executed, read those configuration meta tags and attempt to see if the user has signed in. And the reason for doing that is we want to allow people to move between devices. So if you're on your desktop and you're logged into your Google account and you sign in, you consent. You give it access to that profile scope to know who you are. And then you take your phone out and you've got a Google account, the same Google account on your phone, you go to the site, in that case, it automatically signs you in. It doesn't need to prompt you again, it doesn't need to show you the button. So that just made life easier for us. We didn't have to do so much, and that exchange could happen on the client side. But we still need to identify, we still need to do a little bit of work on the server to identify the user. And in fact, what we do is send back a code from the client side to the server. There's a couple of ways you can do this, but the distinctions are a little bit technical. So if you want to know about ID tokens and OpenID Connect, which is this close to standardization, come grab me after. But this is what we actually get back. So every time the user loads the page, we're going to get a callback to this. Either it'll say, nope, they're not signed in, or it'll say, yes, they are signed in. So if they then press the button, we'll get a further callback saying, yes, they are signed in. With that callback, we get a code which we can send to the server. And on the server, we can exchange that for a token we can use to call the API. And in this case, we're going to call the Google Plus API, which can be used to retrieve profile data. It has a profile section within it. We're looking for the profile of the current user, me, and out of that, we're just returning a hash of information, which we're going to send back in JSON. That's just going to be their name. It's going to be an obfuscated version of their user ID, which is going to be hashed with a rotating salt. And it's going to include their city, which we're getting from the App Engine header. So this is that automatic geolocation. And the point is, we don't put this in a session. We're going over HTTPS. It's secure. We can just send it back to the client. And then we've removed state. Even on a system like App Engine, even on something scalable, the less calls we have to do to anything else, the better. So this way the client can send us everything that we need to record an answer for them, everything that we need to handle their interactions with our app. So the one last thing I wanted to mention is that there's a lot of random little bits of App Engine that aren't necessarily obvious, things we haven't covered tonight, things like task queues and so on. But they all work on that kind of URL pattern. So one we did use in this app, which wasn't used in the One Direction app, was a cron. And in our app, it actually resets. So kind of on the hour, it resets and goes again with slightly different questions. So there's more questions than the 12 that actually get displayed. And the way we do that is by having cron jobs. And cron jobs in App Engine look like this. You have another YAML file, of course, which you deploy separately. You say what the URL you want to call is. You say which module you'd like it to be in. If you leave that out, it'll use the default. And you give it a schedule. And you can do quite complicated strings. It's not the old asterisk, 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 asterisk of cron. It's a little more human readable. So you can write in quite flexible and detailed definitions of when you want jobs to run, and you can say the time zone of it. So there's a special command to actually push that out. And that allows us to kick this job off as we need it, go and reset the database, clear things up, generate new questions. So in this case, you'll notice as well, that URL, anyone could call, right? But one of the advantages of having a Google front end between you guys and the actual servers is that we can trust, if we see the cron header in a request, that it is coming from the cron service. If you try and spoof that cron header, it's going to get filtered out before it gets anywhere near our application. So it's very easy to secure that URL just with a simple check. So finally, we've got the app, everything's there, we've got all the database calls, we've got the JavaScript, and we need to actually deploy it. As you saw in the last slide, we had a tool that we were calling to deploy the cron. That same tool can be used to do a lot of management and configuration of App Engine services. So in this case, we're just going to use the appconfig.py tool to push out each of our modules individually. And it's important to note it is individually. If you just do app YAML, your DB module does not get deployed. You've got to deploy all of them. And that is because they can be deployed individually. You can rev these up as you need them. The other thing that's available is git push to deploy. So if you're using Git already, if you're using git push to deploy on another service, it'll work the same way. So you just get a Git repo URL, you add it as a remote, and when you push to it, that's going to kick off a deploy process that works pretty much exactly the same as the tool. So you will have your new versions deployed. So that's pretty much what we went through in terms of building this little quiz. And what I wanted to sort of leave you with as an idea was thinking about what would need to be done to actually deploy an application to App Engine. Broadly, it is the same as what you would do building any PHP app. But when you're done, think about setting up an app YAML, configuring those different modules, and dividing your service into those differently scalable elements so that you can have the right tools and the right rules applied to each. And think about what your data store should be. Cloud SQL is great, it works. If you need relational data, you can use it. Cloud Datastore is probably easier to scale because it's so much flatter. And you've got, of course, the cloud storage as well for files and so on. And then that's pretty much it. Put the configuration together and deploy it.
So I think I have one key takeaway as well. So if anybody comes to you to say that we want to build an application that's going to service probably up to 1 million users over a 7-hour period, and we need to build it in 3 weeks, I think App Engine is the perfect place to build it. So I think that's what we did for the 1D-Day application. And I think Ian showed a great example of a full PHP application here on the slide today. So I think that's really, really good. So you're going to talk about this?
Well, yeah, we had a lot of links we wanted to put up, so we decided rather than put them all up on a slide, especially because of the last talk, we'd put them on a site. So on that quiz URL, phpukquiz.appspot.com, if you go to there/talk, you will get all of the links, including the links to the slides for this talk, the links to the slide on the talk where we converted joined in, if you want to see more about that. Links to the App Engine SDK for PHP, so you can just download it. And it also includes this Cloud Platform Starter Pack thing. Yeah,
so we've been giving this away for quite some time now, so if you want to actually kick the tires with App Engine, it's free to start anyway, but if you want to do more than just the quotas allow you to do, you can get $1,000 worth of credits for App Engine and $1,000 worth of credits for Compute Engine, although it's for other cloud services. Go to this URL, this short form URL here, and enter the code phpuk-con. There is a process to go through to get all of these credits applied to your account, but it's fairly straightforward, and many, many people have done this so far.
Yeah. And so those all last for a year, so you can really try things out and experiment with it. And that's about it. Thank you.
Thank you very much.